course, in this video we will recover gold from these watches. As you can see, I picked different sizes and different types and different thickness of gold plating. We have men watches, ladies watches, some of them have 5 microns of gold, others have 20. So this is more or less what you can find on the market, buy, and we'll check how much gold is in this pile. But first, before recovering the gold, we have to scrap them. What I already did is I removed the back lids. So when you remove the back lid, let's put it here. Next step is to take the mechanism. Here is the mechanism. I will collect them, and the good mechanisms I'll give to a friend of mine that is repairing watches. Then the watch glass. You just push it like this and watch glass is removed. Then you have the case. Case is plated, and that's what we need for our gold recovery. What is important? I collect only non-magnetic cases. If there are any magnetic parts, I will not take them. I'll put them separately and process them in a different way. In this video, I'll process only the non-magnetic cases. Okay, first one is ready, and as you can see, there are some other that were already scrapped. Let's take one or two more. For example, this one. This is a pretty interesting one because it's Soviet Union, pretty big one. You can see how beautiful it is. So I put the mechanism aside. Let's remove this watch glass, and this is the case, again non-magnetic. So let's put it next to the others. Of course, I'll not waste your time to watch me how I do this for all these watches. Okay, after 10 more minutes of scrapping, that's the final result. We have our watch glasses, back lids made of stainless steel, mechanisms, small parts, and the gold-plated cases. For the purpose of this video, I decided to process only the big parts, the gold-plated cases. I will not touch the small pieces and these mechanisms because, as you can see, some of these mechanisms are gold-plated too. I'll process this in another video. Let's check the weight. Why it's important to check the weight of these gold-plated watch cases? Because this will give us information on how much nitric acid we'll need to dissolve the base metal and to recover the gold plating. Let's measure this. Okay, I'll load the scale and let's check together what is the weight of these gold plated watch cases. A couple of more left. Let's have a look together. Here it is, 145 grams. This means that to dissolve the base metal, I will need at about 3 times this amount, which is 150 to 500 milliliters, 60% nitric acid. To dissolve the base metal and recover the gold plating only. Let's go to the lab now and let's see how much gold we recover from this pile. After 2 hours and 600 milliliters of nitric acid, that's the result. As you can see, some of the watches were really thick, gold plated, and you can see even the case, like, it looks intact, but unfortunately it's only the gold plating. All the base metal inside is dissolved. And from 20 watches, maybe half of them are good quality and thick gold plated, as you can see. The other 10, unfortunately, not so thick gold plating. So you can see the result. It's multiple small gold foils we have. So let's check how much gold we have here, because this is not clean gold, this is dirty gold. I'll move it aside and take my scale. So let's check together how much dirty gold we get and how much clean gold we'll have after I purify this. Okay, no, this wasn't. Let me put it back. And now 0. Let's start. Only this case, wow, it's enormous. 1.3, 1.4. Wow, that's a lot of gold. Okay. My initial suggestion was at about 3 grams of gold, so only the big cases are 3 grams, but now just look at this. 10 watches, 3 grams. Rest is most probably less than half a gram. No, that's a lot. 4 grams of gold, but this is not clean. This is not 24K. I have to clean it. Okay, we start with at about 4 grams of dirty gold plating. Now I will show you how I will purify this and end up with 24K gold. Okay guys, so next step is to dissolve these gold foils, and to do so I will use Aqua Regia, but not the classic ratio. I will use excess of hydrochloric acid. I'm adding it now. This is hydrochloric acid, 30 to 3%. Here it is. And because there are some, let's say, leftovers of nitric acid, you see how solution quickly turns into yellow color. Now I'll put this on the hot plate. It's about 60-65 milliliters. Actually, not exact amount needed. But now what we'll start? We'll start adding small amounts of nitric acid. Let me show you. I'll do it like this. Just drops. And this will help a lot. So I just added it about 2 milliliters. Let's wait a little. Reaction to start. And gold foils to start dissolving. The point is that if you add too much nitric acid, you have to deal with this nitric acid on the next step and remove it from the solution to recover pure gold. So that's why I prefer to work with excess of hydrochloric acid and add small portions of nitric acid until the gold foils dissolve. I started with 2 milliliters nitric acid. Now I'll start the ventilation. It will be noisy, but I'll continue adding nitric acid until gold foils fully dissolve. These were 2 more milliliters of nitric acid, and this is 56% nitric acid. As you can see on the hot plate, solution quickly starts bubbling. Maybe it's good to keep it at about 100 degrees. We don't need high temperature here. Temperature just helps to speed up the reaction of gold foil dissolving. And as you can see, solution is not nicely yellowish. It's a little bit green color, blue color, because these gold foils are not 24K gold. We also have some copper probably. We may have other metals in the solution. So now you see it's boiling slowly, and reaction is going pretty nicely. Let's add a little bit more nitric acid now. So far I added about 7 milliliters of nitric acid. These are 4 grams of metal. Should be almost there, you see, and I will continue this reaction and show you the final result when I reach the next step of filtering. It took quite a long time to dissolve the gold foils, just because there were 2 of them that were super difficult to dissolve, really thick gold plating. Everything else was pretty quick. In the first 10 minutes was dissolved in this Aqua Regia. Now we do 2 filterings. First filtering will be to get rid of our some trash. Now on the next step I will rinse the filter too, and I will rinse it until I see white transparent water dropping, because now I see quite many yellow areas of it, which means gold. We don't need this gold on the paper, we need only the trash on the paper. Let me show you how the filter looks from above. Here it is. Okay, we are ready with this first filtering. Now let's heat a little bit the solution. And as you can see, it's not really perfect yellow. We have a little greenish maybe color, but the next step is very important. If there is any nitric acid left in this solution, we have to remove it. So I put it on the hot plate. We don't need boiling solution, but we need hot solution. And I will start adding small amounts of sulfaminic acid. Really small amount. And it's important your solution not to be boiling and not to add too much, because you may end up with a really nice boil over at that stage. You see how the nitric acid reacts. This reaction, as I said, is very important, not only because it removes the nitric acid, but also because at this stage you're forming sulfuric acid inside. And when you drop your gold from the solution, sulfuric acid will help you a lot, because sulfuric acid is helping gold to coagulate. So you will not end up with gold dust, you end up with gold that pretty much looks like tea. I think that we are almost ready, because I see on the bottom some small pieces of sulfaminic acid not yet reacted. Almost no reaction, I see. Let's add a little more. Okay, almost there. So it can look a little muddy, not so crystal clear solution. That's because sulfaminic acid can form some sulfates that are not soluble. And that's here one more advantage of using sulfaminic acid for the denoxing, because you may clean up in this way also your solution from some impurities, some metals that at that stage will form sulfate. Now we'll do one more filtering. You see the stick is yellow, so we have to rinse it, not to lose this milligram of gold. Let's go to one more filtration now. Here it is. Going pretty well. And you see, at that stage you don't need a vacuum. Gravity is enough to filter your solution. It's going pretty well. I'll filter it and show you how it looks like. So you can see significant difference. This solution is much more transparent than the previous one. I'll put it and heat it. Now we go to the final step, it's gold recovery. First, I will use my magnet stirrer and start it. Not very fast, but just enough to form gold, to coagulate, to get good gold granules, not dust. What we add? This time I will drop the gold using iron sulfate. And when you use iron sulfate, you have to consider you need a lot, because the crystal of iron sulfate contains 7 molecules of water. So it looks a lot, but actually you're not adding that much iron sulfate. That's my point. And about the temperature, I heat, but I do not boil, as you can see. Let's add a spoon. I will add such spoons of iron sulfate inside. Let's add the first one. You see immediately some change of color, but it's not enough. Now it's getting darker. Let's speed up a little bit the stirrer. Now it's better. Let's continue adding iron sulfate. Now I will decant the gold, and because it's super hot, I will use this fabric to protect my hand. So let's decant here. And let's see what we have at the bottom. Okay guys, so that's our gold. Not sure if you can see it, but it's a lot. It's a decent amount. I will rinse it now. First with water. But you see how it's not gold dust. Its particles are bigger, and it's easy to decant and easy to manipulate and to clean this gold, compared to the case when gold is recovered as dust. I'm doing all the washing with distilled water. Someone can say that it's not needed, but I prefer to minimize, and see this rinse water is still yellow. Okay, so maybe now it's better visible that the gold on the bottom. The color is correct. It should be like this. It should be brownish, maybe a little bit lighter. I am rinsing it one more time with distilled water. And of course, this solution, keep it to the very end, because we've seen many surprises. After maybe at about half an hour, I got this gold at the end. You can see it on the bottom. And this is the solution. I will just keep it by tomorrow, and maybe some fine gold dust will fall that I'll collect. So next step, let's dry this gold and let's melt it. So first I start with a very mild flame, and I'm trying just to all small particles that are inside to a little bit melt together. So when you increase the flame on a later stage, you don't blow everything that is in the crucible, but it stays as more or less homogeneous solid piece that will be melted. And this is the final result. Look at this beautiful piece of gold. Doesn't look big, but color is really good, close to 24K, super close to 999. And let's check the weight. It's 2.7677 grams. Pretty good result. We started with 145 grams of scrap, and we ended up with 2.77 grams of gold. This means a little less than 2% gold content of the gold-plated scrap, which is good result. Thanks for watching, keep scrapping, and don't forget to recover your gold at the end. Bye!